Hi and welcome to this tutorial on the uses of group 2 elements and their compounds. In the previous tutorial, we learned about the reactions of group 2 elements with oxygen, water and dilute acids, and we learned how to explain those too. So in this tutorial, we are just looking at the uses of these group 2 elements and their compounds. So we might use magnesium metal to extract titanium from a compound titanium chloride, so TiCl4. So the titanium 4 oxide is the main ore of titanium. And we can use magnesium to help extract the titanium chloride from that structure. So we can react magnesium with titanium chloride 4, and we can get that in our ore, and so we're going to be able to extract the titanium metal, and that's going to leave us with some salt here as well. So I'm just going to balance that. So fractional distillation is used to purify the titanium chloride, and then that pure titanium chloride is able to be put in the furnace. Okay, so we start off with the titanium 4 oxide. We can then heat it with chlorine gas, and that's going to give us titanium chloride. So we start off with titanium 4 oxide, and we're going to heat that with chlorine gas, and that's going to give us this. We're then going to use fractional distillation to purify this, and then we can put that into this reaction with magnesium, and that is going to enable us to extract titanium, which is a very, very helpful metal. You also might see group 2 compounds being used to neutralise acid, particularly stomach acid, for acid reflux, for example. So calcium hydroxide can be used in agriculture for a similar reason. So acid rain, for example, might affect crops, so farmers can put calcium hydroxide onto their fields. And magnesium hydroxide can be used in medicine to reduce acid if there's excess acid in the stomach. So if we wrote this as an ionic equation, it would end up just being a neutralization reaction, of course. So it would just be H plus OH minus mix H2O, because we are just doing a basic neutralization. Sulfur dioxide is an air pollutant released from the combustion of fossil fuels, and we can use something called wet scrubbing. So wet scrubbing, that is the process used to remove sulfur dioxide from flue gases. So powdered calcium oxide, so CaO, or calcium carbonate, so CaCO3, can be used to remove SO2. Okay, that's what we want to get rid of. And a slurry is made, and that's a combination. So if we want to make a slurry, we're going to combine calcium oxide, calcium carbonate, and water. So if we react these together, the calcium carbonate, which is a solid, is going to react, obviously, with the water that we've got in this situation as well. And it's going to react with the gas that we don't want, and it's going to give us a solid and my water here. So that is brilliant because it's gotten rid of this horrible SO2 that we don't want. If I react with calcium carbonate as well, if I just squidge it in up here, so calcium carbonate is going to react with the water that I've got in my slurry. And I'm also, of course, it's going to be reacting with the thing I don't want, the SO2. So what's it going to make? It's going to make the same thing. So SO3 plus 2 H2O plus is going to be some capacity of carbon dioxide as well, of course, because I've got a carbon atom here, so I need it on the other side. And again, fantastic. I've gotten rid of that sulfur dioxide that I didn't want. X-rays, that is also a helpful thing we can use group 2 metals for and their compounds. So X-rays, they usually pass through soft tissues like the digestive system, and they're used to mostly diagnose problems with bones. But barium sulfate, so BaSO4, we know it's a white precipitate, but it's also opaque to X-rays. Okay, so a patient can be asked to swallow barium metal, which contains barium sulfate. And tissues of the esophagus, the stomach, or the intestines will then be coated with that barium sulfate, and it allows those soft tissues to appear on the X-ray. So the radiographers can have a look and check that everything's working the way that it should be.